In this video, we're going to see how we can show that a function is not integrable. So we're going to consider the function g of x given by g of x is equal to 1 if x is a rational number and 0 if x is an irrational number. So we're asking if the function is integrable on the interval 0 to 1. And the key idea here is the following, is that the set of rational numbers is dense in R and that the set of irrational numbers is also dense in R. And I'm going to write here what it means. If I have that A is strictly less than B, so I can form an interval AB. In that interval, I can always find a rational number, but I can also always find an irrational number. That is because when we say that the rational numbers are dense, what it means is that in between any two real numbers, I can always find a rational number, and the same thing for the irrationals. In between any two real numbers, I can find an irrational number. And this idea is going to be very helpful because you see, if I pick any partition of the interval 0, 1, what I'm guaranteed is that when I create my subintervals, then in the subinterval xi minus 1 to xi, I know I'm guaranteed to have an irrational number, and g of that irrational number is 0. So the infimum of my function on that interval is going to be 0. But now again, in that interval xi minus 1 to xi, there is always going to be a rational number, so g of that rational number is 1. So then the supremum of that function on that interval is going to be 1. Okay, so now we need to find the lower sums and the upper sums with those partitions. You see, the height of all the rectangles for the lower sum is going to be 0. And the width of the rectangles, all of them are up to 1. So that is 0 times 1, so that should be 0. And then for the upper sums, we have that the height of all the rectangles we're going to consider is 1. And the width of all the rectangles add up to 1. So we have 1 times 1, that's going to be the area. So the upper sum will be 1. If you are not convinced, I invite you to draw a picture and see it for yourself. Now we just need to find the upper integral and the lower integral. The upper integral is the infimum of the upper sums. But we said that all the upper sums are equal to 1, so this is just the infimum of the set, which is a point 1, so it's going to be 1. So the upper sum is equal to 1. Sorry, the upper integral is equal to 1. Now, what about the lower integral? Well, the lower integral is the supremum of the lower sums. But all the lower sums are equal to 0, so this is the supremum of that set 0. So that tells me then that the lower integral is equal to 0. Very good. So now we can see that the upper integral is different from the lower integral. And that means that my function g is not integrable on the interval 0, 1. Because remember, the definition of not being integrable is precisely that the upper and the lower integrals are different.